Okay, so we will get started. Please go back to your seat, and then I would like to have Matt Kuhn to start. Matt.
Welcome, everyone, to this panel discussion session number 4 of Professor Mitchell's Influence in Geotechnical Engineering. What I'm going to do is begin by introducing the panel members, and then we'll have some general comments by the panel members about Jim Mitchell's legacy, and then we'll have a series of questions that the panel members will address. And then at the end, if we have time, we'll turn things over for questions from the audience. So my name is Matthew Kuhn. I'm a retired professor at the University of Portland. I was a 1987 graduate of Dr. Mitchell's. And let's see, we have 2 current Berkeley faculty members. We have John Bray and Michael Riemer. Okay, they're both Berkeley graduates, of course. And then we have, besides myself, 2 other Jim Mitchell students. We have Scott Huntsman, who is with Woodward Clyde Black and Veatch in Walnut Creek. And then we have another panel member who was unable to come today, unfortunately, John McMillan, who was a 1985 graduate student of Dr. Mitchell. And then we'll be giving some of his comments. He's made some notes for us to present. So I think Scott and I will be doing that during the question and answer period. So we're going to begin with some general statements, and I'll turn things over to John Bray to do that.
Welcome back, everyone. This is my last photograph of Jim Mitchell. It was in May of 2023 at RPI, which was appropriate because that's where he started his civil engineering journey. And like most cases, it was wonderful to spend time with him and to listen to him. Jim Mitchell, I want to start with a slide of my personal, some of the key highlights. And I think as a teacher, you've heard it over and over again. It was soil behavior. I mean, he taught foundations and other soil and site improvement, but he wrote the book and he explained it so succinctly in his lectures, so organized. As a researcher, I was blessed to have him as the second reader of the PhD thesis, and he put some earnest work in it. I got some of the red pen that other people have talked about, but early on in discussions, he got me off of strength and stress and said I really should be thinking about strain and deformation, and pointed me towards some series of articles by Ken Roscoe and others that looked at this strain-based approach. And given my boundary deformation problem I was solving, it was a good direction. And then as a practitioner, with my work primarily in geotechnical earthquake engineering, the area that I see the impact of Jim Mitchell the most was on ground improvement and his legacy in terms of really advancing the state of the art in that area. But then you've heard this before. I remember I had to teach the foundations course when I first arrived here from Purdue in the spring of 1993. And as I'm getting ready, I'm a couple of weeks away, I'm at least thinking that far out, and said, okay, I've got to talk about piles. I worked on piles before, but I wasn't the kind of person to stand back and take pictures of things back then, maybe a lesson learned. But I remember when Jim taught that class, he had some wonderful slides, 35 millimeter slides. And so in the afternoon, late on a Wednesday, I said, Professor Mitchell, I had a hard time calling him Jim. Professor Mitchell, call me Jim. Okay, Jim, I remember you had some slides. In a couple of weeks, I would like to use them. Would that be okay? So I go home. I come back at around 6 o'clock in the morning to start my work, and the slides are right there on my desk. So he is one of these people that listened to you, kindly gave you things, and he gave you instantaneous gratification. But as I thought about this, it wasn't just the impact he had on me. We can all individually tell those stories. I realized that I really understood it from the impact he had on his students. His students made such a big impact on me, and one of them was for the first time, I led a major overseas post-earthquake reconnaissance, was the Kocaeli earthquake, which occurred on August 17th, 1999. First time to Turkey, and I'm trying with J.P. Bardet to get a handle on things, and Turan Duganulu contacts me, says we should meet in the lobby. And this is where it's not just Jim, but it's Berkeley and Turan's love for Berkeley, that he said, you really should meet with me. And meeting with him in that lobby before I went to the airport was just changed the way I did the work. And so this is actually a picture of Turan, and you can believe the shapes. Maybe from the shapes you can get it figured out. But he really embraced me and embraced my PhD student, Rodolfo Sancio, adopted us both, and really provided tremendous resources, technical insight and important information, but also guidance, the use of the CPT. And in fact, this paper, Subsurface Characterization of Ground Failure Sites in Adapazari, Turkey, which was published in 2004, he deservedly is the third author. Other than the work that Rodolfo Sancio and I did in the field, no one made a bigger difference to this work than Turan. And that later led to things like Bray and Sancio 2006. And so Turan is really a passionate lover of Berkeley, but really, from the first time I met him, Jim Mitchell, I've never seen somebody with more outpouring support for this person who thought changed his life. And he really desperately wanted to be here, but he wasn't able to be here because of a medical reason. But this is how dedicated he is. I found out that he's having a Jim Mitchell symposium in Istanbul today. And so he gathered together the people from Zeytas, Boğaziçi, the local universities, and all the people that Jim has touched in the Istanbul, Turkey area, and said, let's remember Jim and his legacy today. So they're a little bit ahead of us in time. It started at 4 p.m. Istanbul time, so there may be a little bit of overlap in terms of celebrating. You know, the sun never sets on the life and legacy of Jim Mitchell. A couple of points here, and he talks about the excitement. Almost like he's a young boy when I go back and nozzling him, thinking about when they first came here and the Volkswagen bug and all the different stories about the lunar soil experiment project, being able to work on that penetrometer with him. It was used in the Apollo 16 mission. And he also talked about this, and I didn't know about this until the letter that Turan wrote, which I gave to Rick to give to the family, that he actually devised an idea of essentially excavating the slope and then having an astronaut. With all that great training, they're essentially a dead weight. Put them on the edge of a slope and then be able to back figure from the slope stability analysis what the strength of the lunar soil is. And at the very end, this is directly the last line from Turan's letter, Jim's legacy will forever remain an inspiration to those of us fortunate enough to have worked with him. So thank you, Jim Mitchell.
So these comments that are on the screen right now are from John McMillan. I think I mentioned that he was unable to attend. John and Scott both graduated in 1985, Jim Mitchell students. I looked at the list of Jim Mitchell's students. There were 9 students of his graduating in 1985. So try to wrap your head around that. I think Robert Leong was another from that year. But what John McMillan wanted to point out was that Jim Mitchell's contributions were on the basics of soil mineralogy, the effects of temperature, pore fluid properties, and the interaction of the pore fluid with particles. And then he also pointed out something that I wasn't aware of, that John and Jim together had developed some instrumentation for some of the experiments, I believe, that were taking place at Richmond Field Station for thermal effects around electrical cables. So Jim Mitchell made these contributions to instrumentation as well as all of his other contributions. And then the other thing that John points out, I think it's the third bullet there, is that Jim was very willing to take students to conferences. I think we heard of that from Albert Young today and some of the others, and to get his students connected with the industry and with the field. So those are John McMillan's comments, and I think I'll turn things over now to Scott Huntsman.
Thank you very much. My journey with Jim began almost by accident, actually. I was an undergraduate at Cal, went through the civil engineering program, got interested in geotechnical engineering largely because a course I took from Berkeley, Geology for Civil Engineers, and that pretty much got me hooked. And then as a senior, took soil mechanics with Harry Seed and a few other things. Decided I wanted to stay on and get my master's degree, which I did. Then I went out and I worked for about 5 years at what was then Woodward Clyde Consultants, and got interested in a bunch of different projects and things like that. It was always in my plan to go back and get a doctorate, and so I corresponded with Professor Houston and Professor Duncan, and they accepted me back into the program. And I worked a lot with Professor Houston on trying to develop a thesis topic, and he was very interested in ocean engineering at the time. So I read a lot of papers along those lines, and we were having good discussions and developing a topic. Then one day I'm sitting in the lecture hall in Davis Hall, and Professor Mitchell walks in and makes a public announcement that he needs somebody to carry on the work in cone penetration research. And that was just as Phil Tringali and Billy Valet were finishing up their work. And so I raised my hand. I still remember that day, and I consider that to be one of the more important days of my life, along with meeting my wife and having my children, of course. So I would put them ahead of him, but barely. And so we spent a lot of discussions. Well, the first thing he did is he handed me Durganoglu's thesis and some papers he had written, and I almost memorized them. I went through them so carefully. We had a lot of good discussions about, what appropriate topics were going to be, as I was helping Phil get out of town and finish his work, of course. And eventually we settled on measurement of lateral stress with a cone penetrometer. Now, when you think about it, lateral stress is a zero strain phenomenon. And we were trying to measure it by forcing this device into the ground. Had some limited success. I did a bunch of chamber tests with it. I actually had the opportunity to do some field testing on a couple of sites, one up in Canada, one out in the Santa Barbara Channel. And like I say, we had some success with it. I counted up when I looked at his list of PhD students, I was the 6th of 12 people doing cone penetration research. The first was Durganoglu, of course, and it continued through several of us, various different aspects of cone penetrometers. So like Matt said, 1985, I finished my thesis. I didn't realize there were so many of us that year, which is something because Professor Mitchell was also chairman of the department at that time. And so how he managed to handle that workload is beyond me, but I do remember a few things about him. One, he always emphasized to us that the research dissertations was the student's work, it wasn't his. And he said, my door is always open. If you need something, come and talk to me. And whenever I did, it was invaluable to do so. But he largely left me on my own and left me to come talk to him. And it worked out great. He was a great supervisor. I thoroughly enjoyed it all. I'm glad Robert mentioned the Christmas gatherings out at his house in Moraga, and we always played parlor games there. which were fun, sort of an icebreaker to get to know. But the other thing I remember about him is he always took a couple of minutes to thank the spouses and the boyfriends and girlfriends, significant others of all his students for their support and patience in this process. And I always thought that was just a nice thing for him to do. So I eventually got my degree. I went on to various consulting projects, unlike my co-panelists up here. I never did go into academia. I was a project-oriented guy. I went out and kicked the dirt a lot and figured things out. But I always took, the lessons of Jim and his reputation with me. It always got me a level of respect when people knew I was a Jim Mitchell doctorate. And it opened doors for me my entire career. To correct Matt, I am retired now. I'm no longer with Black & Veatch. I spent 12 years with them, but I retired a year and a half ago. And but I'm very happy to be here. And I know I'm preaching to the crowd. All you have to do is look at the people in this audience, look at the people on his list of PhD students, and I believe I'm number 38 of 72 or whatever it is. So I'm pretty much right in the middle. But how many people that were students of Jim's have now become mentors to the next generation? And actually, we're getting old enough where the next generation is now becoming mentors to another generation in there. So clearly, there's a family tree of influence that Professor Mitchell had, and it clearly shows.
Thank you. See, Michael, would you like to?
Sure. So my name is Michael Riemer. I work here since 1989, according to my employee records. That's when I got hired as a GSR. But I kind of represent both institutions here. I was a Virginia Tech person first, and I am only a Geotech because I had lectures with Mike Duncan there. And I finished my undergraduate, and I was so into Geotech in Virginia Tech that I used all my electives to take as many Geotech classes as I could. And so I had already done 2 or 3 of the graduate Geotech classes there. And I was finishing up, and Professor Duncan suggested I might want to consider graduate school, and I was. And he pretty much told me my 2 acceptable options were to stay there or to come to Berkeley. And that was in 1985. 1986 is when I finished there. And there was a In Situ 86 conference. A lot of people here were probably there. Perhaps that was my first chance to meet Professor Mitchell. And I decided, for some personal reasons too, Virginia's beautiful, but I wanted to see California as well. So I came out here, and it was a really good decision for a lot of reasons. But one of them was the exposure to the classes here, the master's classes here. That year of master's classes, I think, is hard to replicate or overemphasize how incredibly useful that is. And hopefully still is for those of you doing it now. But Jim's classes were really different and really eye-opening to me. I think in the same way that the book is so different, he just had such a broad perspective on soils, and not just, here's our best correlation to relate the one thing to the other thing, but not a lot of equations, a lot of factors that affect this. These make it go up, these make it go down. But why? And thinking about the why. And it really personally made me feel like geotechnical engineering was less empirical, I guess, and also that it had this sort of framework underneath it of reasons that things happened, and that was new to me in my exposure to a lot of geotech. So I stayed on and did a PhD. I worked first with Harry Seed, and then when he passed away 2 weeks before my qualifying exam, I was sort of inherited by Ray Seed, and I finished up my work with him. And I initially was going to do some modeling, but first we had to have a data set to compare with, so I did some experimental work. And I made the mistake of doing more than one kind of experiment because they didn't agree. And then I had to do a third kind of experiment, and that didn't agree with the other two. And so my thesis actually shifted toward all experimental work. And in the process, I used pretty much all the equipment in the lab. And I have to thank Clarence Chan for his training and mentorship and patience with all of that. But it turned out that I finished my dissertation just as Clarence was retiring. And so I stayed on here sort of subbing for Clarence for a little while we all sorted out what the long-term solution would be. So in 1992-93 was the one academic year really that I overlapped with Jim still being here and not retiring yet. And I taught the lab class for the first time that year. But when I think back to that time, I had interactions with him as a colleague somewhat, but it's not any of the specific technical things that come back to me. It's his generosity that comes back to me. And the two most prominent of those, I don't think I appreciated one of them at the time, but he had a consulting project over in Half Moon Bay, and it wasn't a particularly extraordinary project, but he needed to do a site visit and meet with somebody for a little while. And kind of out of the blue, he asked me, "Oh, would you like to come along?" And sure, that would be interesting. You know, I haven't been on consulting projects. I'll see what it's like. And it says something about the project that I really don't remember much about the project. That was not the highlight for me. I would say the highlight for me was sitting with Jim, carpooling there in his car, spending the afternoon talking with him. It was like the most opportunity I ever had, that before or after that, to talk with him about things. And I realized later, much later, that he, reached out on purpose to help make sure I was feeling okay as a new person in the program, to ask me about not just my research interests, but about my life in general, my goals, things like that. And he gave me some subtle but really good advice about life balance and things like that. And so I gather from today's discussions that this was not unusual, but it was really useful and important to me. The more practical, maybe last thing, influence-wise, was as he was retiring from here, he needed to sort of divest from some of his research projects, and he generously suggested to the research people that I could take over this kind of medium-sized project that he was doing on remediation of bridge foundations. And so first he involved me, and I was working with him and with Thomas Locke, who was doing the student part of the work. And then as he retired, I got to have the experience of being the PI and working on that project from that perspective. Of course, then, shortly thereafter, he unretired and decided maybe it was better if he actually finished up the project as the PI again. And so it's like, okay, that's fine. Yeah, I had the opportunity as PI for a little while. I continued to work on the project and continued to learn from him and the way that he approached research, which was also super valuable. So,
Thank you. Well, we've finished with some general statements about Dr. Mitchell's influence on geotechnical engineering. We have a few questions, and the first one is, can you offer examples of geotechnical subdisciplines that were profoundly altered by Jim Mitchell. And I'll take this one myself. And what I thought I would do is just focus on a 10-year period of Jim Mitchell's career. And I'll call this the first set of miracle years, because more miracle years were to follow. But this was, let's say, from 1962 to 1972, that period. And I kind of rely upon the GeoLegends interview that Rudy Bonaparte had with Jim Mitchell. It's a wonderful interview, Rudy, and it really shows what a kind soul Jim was. But Rudy sort of asked Jim about questions of his early career. And, you know, when I watched that, it seemed as if Jim's early career had kind of an Alice in Wonderland aspect to it, because I think Rudy asked him, well, what was one of your first projects? And Jim says something, well, there was another engineering professor that asked him how to make any soil into hard pan. Yeah, basically soil improvement. And Jim, I don't know that he was actually involved with soil stabilization and improvement before then. This was around 1962, I believe. And this developed into several PhD programs and really kind of set the basis, if you will, for soil improvement, ground improvement, soil stabilization as a field. And then the second thing that happened in that 10-year period is that for some reason, I don't really know why, he got interested in the question that Albert had raised, how fast? How fast do things happen? And I'm not sure how he came about it, but he learned about rate process theory. It's this approach that's used in chemistry to predict the rate at which chemical reactions take place. And Jim Mitchell did something unusual. He wrote a sole author paper. And if you look at his vita, there are very few of those. There's, of course, the Terzaghi and Rankine lectures and a few others. But he must have done a very deep dive into this chemistry kind of abstract theory. And he was later joined by Richard Campanella and Attar Singh, who developed their creep theories. So that was the second thing that happened in these 10 miracle years. And then somewhere along the line, there was a PhD student, Donald Gray, and I think Catherine has mentioned his name and some others also, and Albert. And he came to Jim Mitchell and said, I'm interested in coupled transport processes. How strange, right? This is back in the mid-1960s. And Jim agreed to take this on. And by Albert's telling of things, this really developed into what we now call geoenvironmental engineering, okay? And it involves those four processes that I think Catherine mentioned this morning about the transport of electricity, fluid, chemicals, and heat. I think I've got them all in there. And then the fourth thing that happened in the miracle 10 years was he got wind of an opportunity with NASA. Okay, that they were interested, that the president of ASCE was interested in getting a civil engineering presence within the NASA program. And Jim Mitchell just takes it on, you know, and and it was shortly after that that Duran Oglu was with his PhD program, and that developed into the site characterization and CPT work that that Jim Mitchell was involved in afterward. So there are these four different things that happened in his miracle 10 years. There are probably others that I haven't come across, but you know, you look at this and you think, well, it's kind of like Alice in Wonderland. It's this kind of serendipitous stumbling into things, but that I don't think that was the case. I think Jim just had an innate curiosity about things, wanting to get to the why of things. And it was not just being curious. He was willing to take on these problems. Actually, not willing. He was courageous to take on these problems. It takes courage to just throw yourself into a new topic. And then, of course, Jim Mitchell had these wonderful abilities of communication, of leadership, of organization. And these were all in one package, and I think that's why we're one reason why we're honoring this amazing person. Would anyone else like to offer thoughts about other geotechnical?
Just one more thing is when I had a chance to do a peer review of the Turnagain Heights landslide in the mid-2000s, it was a joy to go back to the 1964 Anchorage Soil Study Report. If you haven't read that, it's really worth looking through it. And a young assistant professor, Jim Mitchell, looks at the chemical analysis of the Bootlegger Cove clay, tremendously insightful. And then when I think about something that permeates almost through everything, it's compaction. You know, you look at the Strength of Soil Conference, as well as the journal articles at that time, many of these papers with Harry Seed and Clarence Chan, just look at the fundamental aspects of compaction and the effects on properties. That's the basis, along with the work that Lamb and Whitman did in the late 50s, to me, of all the work that I have seen of merit in the geoenvironmental aligners, it's in those papers, and it's tremendous how it's worth going back and reading those when you start to look at future problems.
I suppose I can add to that. I think there were very, very few subdisciplines in geotechnical engineering that Professor Mitchell didn't have an influence on, all the way from microscopic and submicroscopic intrinsic properties of soils, all the way up to empirical studies of the behavior of soils and the behavior of structures interacting with soils. So I think, you know, one could classify him as a generalist, I suppose, because he touched almost every subdiscipline of our business.
Thank you. So our next question is, why or how was Jim able to contribute to such a wide range of fields? I think we've answered some of those. Scott? Yes.
No, I don't have much more to say on that, but I think it's just he had a talent for doing that, and he was curious. He let the students take the research where they wanted to take it, and I think that was the benefit. I think it's worth noting that in this morning's sessions, I think it wasn't until Rodrigo's that anybody mentioned friction angle. He didn't really see clay as friction angle and cohesion. He saw clay as this molecular model here, more, you know, minute particle interactions. And I think that's how he was able to be such a contributor.
Yeah, I would just say that, elaborating on what John was saying a little bit about the compaction, that he was really setting a stage or a framework for looking at soil in a different way, maybe, that it was not just something you had to deal with as a foundation material, but it could be used as an engineering material. And soil improvement, you know, goes along with that. But in terms of this question and why he's able to be so productive across so many fields, it's a combination, right, of the curiosity and the organization and the willingness to turn it over, to delegate it, to let the students run with it and enjoy their progress, have his questions answered without having to do all the research personally, right? That's how to be effective.
Yeah, and I developed a scale as an assistant professor, and you start getting stretched to try to evaluate whether things are getting out of control. And so, we use the plastic limit and the liquid limit and the water content. And so I evaluate my content against the Mitchell limit. I could never get down to the Mitchell limit, but the closer I got to that, the more organized I was. And then when I got to I was going in many different directions, and there was another person that was at that other limit, I won't mention the name, I realized, okay, I need to take fewer things on, I need to get refocused, I need to get back down to the Mitchell limit.
Good, thank you. Let's see, we'll go to the question. His 78 PhD students, I think it's 78, maybe we're 78 plus PhD students have certainly had an influence on the geotechnical profession. What were some of the important lessons and abilities that Jim imparted to these students?
Well, I certainly think one of them was balance. Like Rick mentioned, he was home at 6:15 every day to spend the quality time with his family. And he understood that all of his students had private lives, and he encouraged that and fostered it, I think.
Yeah, I think I could have another take on that. And it's this kind of entrepreneurial aspect of Jim Mitchell. And I'm thinking about the way that I got involved in particle mechanics, discrete element method mechanics. And I was in my second year of my PhD program. I had already done 2 years of experimental work. It was on a project, the one that Ed Kevazanji had begun, and Rudy Bonaparte had worked on, Robert Leong had worked on. Anyway, so I was 2 years into this thing. I was already starting to write the dissertation. And for better or worse, I met another geotechnical student, another PhD student, and I don't remember who it was, but he said something. He said, I saw this presentation a week ago. It was by this engineer at Lawrence Livermore Labs who was working on this, I forget the name of it, he said, but it was about these little particles and how they interact. So I said, okay, I took that in. Next time I saw Jim Mitchell, I said, I heard about this thing, and by that time I knew the name of it, discrete element method. And the man just about jumped out of his chair because he had heard of it, definitely, and recognized its potential. And he said, well, Matthew, try to find out who this guy is and see what you can learn. So I found out the guy's name. I dialed down to Lawrence Livermore Lab and got in touch with a man named Otis Walton. And by the way, before I left, Jim said, if it looks like a go, you let me know and I'll find the computer for you to do that on. Okay? So sure enough, I got back and there was a computer waiting for me to use. And some of you probably use some of those ancient things. But what was remarkable was that he recognized that potential. And, he was more excited about it than I was, really, because I was already 2 years into this thing. And I was beginning to realize that I'm starting phase 2 of my PhD program. But Jim Mitchell was all in on that. Well, let's see. I think John wanted to answer this question about Jim's teaching advances. How did Jim's teaching advance our understanding of soil behavior?
And I think you've heard that. I mean, it is a unique book, and it provides an alternative view of things. Looking at soil as a particle. That's one reason why I saw Genhua Shi doing things with two-dimensional blocks with DDA, and I thought, someday we're going to be able to do millions of particles with DDA or DEM. I should pay attention to that. And seeing particles as individual particles and seeing the interaction, I mean, that's kind of woven into soil behavior. It's also in the Lamb and Whitman book as well. Those are things that really change your view. I came into this field as a structural engineer with a master's degree in structural engineering, and we typically go, you know, what's the C and phi, what's the strength, what's the stress, to be able to kind of see things not as a continuum, to see things as individual particles interacting and focusing on strain. Failure strain is just as important as strength. Those are important things for kind of bending your brain into a different direction. And Jim had a way with his questions and his guidance to offer you the opportunity, he never made you, offer you the opportunity to go in different directions. And you were wise if you listened to him.
Well, let's see. Our last question is, what topics would Jim be interested in investigating today?
Well, I think the obvious one is the field of biomodification of soils that Ed Kavazanjian is largely spearheading these days. I think that would be a natural for Professor Mitchell to get involved with and get excited about.
I think he'd be in mine tailings, because I think that when you think about it, you understand soil behavior. One of the more challenging, because of the interactions and the pore water chemistry and some of the way you extract the minerals and the material that's left, and given the impacts that have happened, he was drawn to understanding failures, whether it was Kettleman Hills or other failures. So I think that Brumadinho and some of these failures would have ignited his passion. He has the fundamentals of understanding particulate matter and understanding material interaction, particle interactions. I could see him working aggressively in the mine tailings area.
I guess my answer would be we can't even dream right now of what he would be interested in. It would probably be in some unusual recondite area that it's hard for us to imagine. He had such a fruitful intellect and curiosity. Are there questions? Do we have time for questions from the audience, or should we move? Sure. If would someone like to either offer some thoughts or?
You want to get the microphone?
Here's Rudy. Thank you again, Rudy, for that GeoLegends video.
The thought that comes to mind, amongst other areas he would be interested in, and I agree with mine tailings and the other things that were mentioned, how about Martian soil mechanics?
You're a dreamer, Rudy.
Probably Jupiter.
Yeah.
Comments or questions? Well, I think we're finished then. Yeah, thank you, Kenichi.